We finished all the parts for all the weld boxes and sent them out for heat treat. And they put me as doubly tool right. I'm doubly tool right. And the parts came back looking beautiful. I don't know if you can see this, but they've got kind of a gold patina on them. They definitely sound different. They definitely sound harder. If this gives you a reference, here is a piece of D2 as I got it versus the D2 after heat treat. It's really obvious to me. This is gold colored and this is silver, but I don't know if you can see it. So that's pre-heat treat, post-heat treat. I also sent in my 2 tap guides just so I'd have something I could hardness check, because I figured why not, see how the process worked out. The company that did my heat treat is Burbank Steel Treating Incorporated, and not only do they do a really good job, but they're really quick. So I've always been really happy with them. I've used them twice now, always. I've used them twice now, and they've been great twice. So you can check them out if you want. If you live in the Southern California area and you need some heat treating, I recommend them. They do more than just plain old heat treat. They do nitriding and all kinds of things. Check out their website for more. And by the way, they're not paying me to say this. I'm just giving them a plug because they work really well. All right, so I've got one of my tap guides in here. Figured dinging that up's not going to matter. And we'll set this thing to preload right here. Try and get right on the dot. Zero this guy. Now, when I was giving them what my heat treat requirements were, I was shooting for hardness more than I was shooting for toughness, because these parts don't see a lot of, impact sort of wear on them. They mostly are going to have abrasive wear, so I wanted them to be really hard so that they'd be maximum abrasive resistance. I didn't give up toughness altogether, but it looks like we're at Rockwell 59. So that'll be perfect. All right, so here's all 5 sets of hardened modified parts that we have made out of D2 tool steel. They definitely sound different than the metal before heat treating, which is kind of cool. They're a lot harder. They're about Rockwell 58 or 59 based on my tests. And they're ready for installation. So we're going to put them in, and we're going to make sure to label the old ones when they come out so that they can, be used as reference in future if something needs to be made or they need to be put back in for some reason. Now, I do have concerns because these were sent out for heat treat. I tried to leave them a little bit sloppy just in case they change dimensionally, and that's going to be a big concern going forward. Like, are they going to actually fit? So I guess we'll find out. We'll try the first couple. I won't make you watch all of them because it's a lot. All right, here's Weldboxes X1, X2. Those are Xboxes, right? Anyways, they actually think they're called A in their notation, but these are the ones made out of brass, and the customer decided that we wouldn't remake these, especially since they'd have to be redesigned. I couldn't just make pieces for them because there's no room the way they built them to add the extra access, like the other ones have. Because then there'd be nothing to guide the material around and nothing to hold the bearings in place. They kind of made it an all-in-one. They didn't design it for that. So I'm just putting these back together, and we're going to send these back to them as is. They will just use them. Fortunately, of the profiles they need to make, these boxes, which are identical, there's 2 of these. I thought they were different, but they're actually the same exact part. And they will be making the fewest of this particular profile. So hopefully they'll last a while. As we put this weld box that is unmodified back together, you'll notice the design of this weld box is actually different than all the other weld boxes. So in this case, it was designed properly. So you see the screw I'm putting in, that's one of 2 that holds that bar in place, and it pulls the bar towards the frame. The stainless steel screw next to it and the one on the other side of my thumb there push the bar out. And their job is to put counter pressure to keep the bar in a specific location, because you can't just tighten it in place. These are designed to be adjustable. As a result, this pulls the bar fairly evenly. However, every other weld box, they put the tightening screw or the pull screw at one plane and the push screw in a completely different plane, which causes the parts to cant. So on the one weld box I modified already, I had to add some really small set screws that could counteract that canting force to keep the part that's in there parallel, because it needs to be. Otherwise, it only touches at a line, which is very problematic. So not a good design. I have a feeling that I'm going to have to do that with some of the other weld boxes. I just didn't know because I didn't have profile material for every one of the weld boxes. They did make the parts a pretty tight fit. Actually, these brass ones are by far the tightest fit. I end up having to use a hammer to tap this one into place. And if I remember right, when I disassembled it, I also had to use a hammer. This one is the closest fitting weld box of them all, both X ones actually. And it's really not necessary, especially when you're doing something like a weld box, because you're expecting a lot of heat to go into this and things are going to expand differentially. So some parts are going to be hotter than the other, because remember, this is laser welding. So the heat is at really one point and sort of diffuses out a little bit, but the rest of it takes a long time for the heat to get there. And all of this is very problematic. I don't think this company did a particularly good job of planning for this sort of issue. And they could have, because they work with the company that I do consulting for on a regular basis, making weld seaming tools, and they do all the hardware design. Or maybe they just make the hardware, they don't design it. I'm not actually sure how that works out. They've done a really good job in the past, but with these, I was not impressed. Now on to the weld boxes that I did make parts for. And first thing is, I'm going to make sure that all of these labels are readable, because all of these parts are very similar between weld boxes. Some of them identical in gross appearance, but they did not make things the same. It is so weird. They're they're all a little bit off, so they're probably not interchangeable, even though in a lot of cases they're identical. And that caused me a lot of grief. If you watched the previous videos with this project, you will have seen the amount of grief I went through. So now that I'm putting the old parts aside, we're going to try and put the new parts in. And I quickly discover the first problem with the heat treat, which is that unlike the first heat treat set of parts I did, on this set of heat treat parts, the countersink holes for the Allen head cap screws shrank, and they shrank just enough for the Allen head screws, the head, not to fit. It is really odd. I don't know why this time it did, and it did on every single part this time. Last time I made 5 parts, 2 of which had recessed countersunk holes like this, and they were fine. This one, I did 5 sets, and you see it spinning there. I'm thinking, oh man, maybe the threads aren't lining up. So I was starting to panic. I was going, oh, that would be a really bad news. But no, when I go to do the second one over here, let's see, still trying the first one. When I try the second one, that's when I figure it out. And sure enough, the cap screw head will not fit in the hole. Now I do have a carbide countersink for these, but I think that would be a huge pain to try and countersink this. So instead, what I'm going to opt to do is I'm going to go over to the lathe. I'm going to make a fixture to hold these Allen head screws. And then I am going to reduce the diameter of the heads by, I think I reduced it 50 thousandths. They only need like 20 thousandths. They're really close. Very odd that this time they don't fit. And right here, I'm just lamenting that, darn, they're really close. And again, the first thought through my head is, damn, these parts are Rockwell 59. I'm not going to be able to do much with these. It's going to eat up tools like crazy. But then I realized, well, the screws aren't that hard, even though they are alloy screws from McMaster Carr. They're much, much softer than the base material here. So we'll make that fixture, reduce the head of all the screws for all of the weld boxes that have countersinks. So there's 2 parts in each weld box. To make the fixture, I'm just using a piece of 1/2-inch cold rolled steel. I'm going to square off the end, and then I'm going to reduce the diameter so that it is somewhat smaller than the final diameter that I want from the cap head screws, so that I can just run the tool right across it. I've got quite a few of these screws to do. I believe it's 20 of them. And then I've got to drill and tap the center of it for M6. Now that we have the modified screws, they're fitting nicely and the holes are lining up. So interestingly enough, dimensionally, the parts didn't shrink or expand so much that the holes didn't line up, just the countersink hole, which, like I said, it was not like a precise fit or anything. It was a standard countersink. The remaining 3 parts mount to the top part of the weld box. And I discovered another thing that I did not, I blew out all of the holes that I threaded, but what I discovered was that even the little debris in there that got hardened, it's kind of stuck to the metal, and I have to chase the threads on every single one of these. Fortunately, and they're hard. The tap I was using was a really high quality tap, and it ended up chipping a piece of the tap by the time I was done with all, I don't know, what is it, 25 parts, of them 3 in each. So 15, after I had to do 15 parts, 2 threads each. It took, you'll see that I start struggling with how tight it is. And it actually takes the threads, those little particles of hardened metal in there that make it so stiff, actually take the threads off the alloy cap screw. So I end up chasing all of these threads, and then I can assemble these boxes without any problem. And they fit perfectly. So fortunately, the 45-degree chamfers I've designed this with fit nicely in that 6 millimeter radius corner in the pockets on this guy. They just freehand sanded all of theirs, which made it a total pain trying to find edges because everything was freehand sanded after it was, the reference point for the dimensions. So these fit nicely. I had to do, like I said, I had to chase every single thread. You notice on this one that the jack screws are above the screws that pull toward me. The ones above that push out and cause it to cant, which is a really stupid design. And I have to, they may end up having to modify these further with that small set screw I did earlier. But other than that, these go together pretty nicely, and everything fits better than I expected. I thought I was going to have some problems. It turns out I didn't have very many. On a couple of the parts, it looked like the pieces, the insert pieces that I made, expanded enough that they were a little tight going in. So I freehand sanded those down, following their example, because it was such a good example. Because I didn't want to try and machine Rockwell C59 material. But yeah, we get this to fit pretty nicely, and the box goes together, as do the remaining 4. I sort of jumped through this stuff because I didn't think you wanted to watch all of the tedious screwing. There are a lot of screws that have to go back in these parts, but it went together fine. The big question will be, how does it work for them when they go to tune this to the specific raw materials that are going into this weld box to be welded? Hopefully that won't be a problem. They'll get back to me and let me know. All right, so we're done for now, but I think there's going to be follow-up to fine-tune these things. They're kind of clunky. Not my design. This is a 5C collet to hold these needle things that they weld a tip on. It's made out of brass. It's a 5C emergency collet. It's made out of brass because the other ones were marking up the pins. So anyways, that's it. I hope you found this project interesting. There's probably more to come. Thanks for watching. Hope you find it useful. Hope to see you next time.